that is why those are the paths we see.
This explains how light knows where to go. I mean, it doesn't. It just explores all possible paths. But the paths we end up seeing are the ones that interfere constructively. And those are the paths of least action. So really, this is how classical mechanics emerges from quantum mechanics. It's why a ball follows the trajectory it does, and how planets orbit the sun. They don't really have a precise trajectory. Instead, everything explores all possible paths. It's just that massive particles have large actions compared to h-bar, so that only paths extremely close to the true path of least action survive, which is why they're much more particle-like. If you go to much smaller particles like electrons or photons, the actions are much smaller, and so there's more of a spread in which trajectories they actually end up taking. Now, you might say, I still don't believe you, but Casper has this incredible demo that should convince you 100% that this is really how the world works.
To do it, I've got a light, a mirror, and a camera. Now, there are infinitely many paths that the light could take. And according to Feynman, we have to add up the contributions of each of them, including paths that go like this. Now, you might say he's crazy.
I'm not crazy. That's what happened. Another possibility is it could come here and go. Or it could come here and go. Or it could come where you'd like it to come and go. And it can go over here and go, and so on, and so on. And these are all possibilities.
And every single one of these paths has their own little arrow. So what we can do is we can look at all those arrows and see where they line up. And so if I turn on this light, that's exactly where you see it reflect, so that the angle of incidence is equal to the angle of reflection. But now what I'm going to do is I'm going to cover up that spot so that we no longer see the light reflect. And then I'm going to prove that Feynman is right, that really light also goes like this. It's just that most of the time, those effects are canceled out. Now, that sounds impossible, right? But let's zoom in to this tiny piece right here. Then we see all these different paths and all the arrows just go around and around in circles. So when you add them up, they all just cancel out. But what if I cover up about half of them like so? Well, now when I add up those arrows, you suddenly do see a large resulting arrow. And so if I can somehow cover up this mirror in many, many tiny strips, then I should be able to get the light to reflect like this. And I can do that with this piece of foil right here. On this piece of foil, there are about 1,000 lines per millimeter, and that should be enough to get this effect. So let me turn off the lights. So let's see. I'm gonna turn it on in 3, 2, 1. We see it! We see it! Ah! That is so cool. It actually looks a lot weirder than I was expecting it to. I was expecting more like one spot, but there's many, many spots where it's reflecting. Ooh, okay. Okay, and just to show I haven't been cheating you, right underneath is my finger. And even with the light on, you know, we see the light reflect. And if we remove the cover, then what do we see? Yeah, we see exactly the normal reflection where it's always supposed to go, which is right there. And then we've got now all these extra reflections, all these extra bits where the pattern just lines up. So very, very cool. When I was talking about this with a friend, actually, he said, yeah, but you're using a diffraction grating. That's kind of like cheating because you get all these other reflections right now. And this light is just going in all directions. And so there's one other thing I've been super, super curious to try. I also want to do this with a laser, where I shine the laser right next to it. And then if light does take every possible path, we should also see it come off here. It probably shouldn't work. I actually have a laser right over here. And we can see when I shine it, it really does just go to one spot. And you can see where that spot is. It's right over there, which is about the same place where we had our reflection. And you can also see right now, if we look at this view, that you cannot see the laser light at all, right? Like I could see the laser, but I have to bring it down all the way over here. And then I'm able to sort of see the light. But if I just put it up here, you can see the reflection.